chains of transformations. And for this, I need to talk a bit more about unsupervised learning. So as we've seen before, unsupervised learning, such as PCA, can be used to transform the data. We've seen this before. We can reduce the data set to lower dimensions using PCA. For this, I need to call the PCA.transform method, and what it does is it returns X, but transformed in a certain way. Here, the transformation is it's reduced it to 2 dimensions. So this is the data of the irises reduced to 2 dimensions. You can see that here it worked quite well because I can easily separate the setosa from the others. We can do this with more complicated models, but I will skip them in the interest of time. And now I want to illustrate how we can chain transformations. So we are going to be looking at chaining a PCA with a support vector machine. And we're going to do this on a data set of faces. So these are the faces, and we're going to try to recognize people in these faces. As a disclaimer, the state of the art to recognize people is not to use SVMs or even to use scikit-learn. Face recognition should be done using deep learning. It's the same underlying concepts than those that I'm talking about today, but with more complicated models. So what we're trying to do here, we're going to try to do a very simple model because we don't have a lot of data. And what we will do is that those faces are very high dimension. So we're going to use PCA to reduce the dimensionality. And then we are going to use a supervised learning model on top of this. So we're going to need to chain PCA and the supervised learning model. Okay, so the first thing we'll do is we'll split our data in train and test data. Then we will use the PCA to reduce the dimension. So we will fit the PCA on the train data. And I'm just going to skip this, and we can transform the data to obtain a reduced data. And we should transform the train, but also the test. Okay, so we fitted the PCA on the train, and then we need to transform the train and the test. So we have a reduced dimension. We only have 150 features now. And then we can use a supervised learning model. And here we're going to use a support vector machine. And we can fit it on the reduced data. And then we can predict. And here we are predicting. Okay? So, and we can measure the important thing is that we are predicting on the reduced data because the SVM has been fitted on the reduced data, so we need to use the reduced data to predict. And we can measure the error and find that it works reasonably well. Now, something that is important is that I need to fit the PCA only on the train data. Because if the PCA sees the test data, then it will not give me a good evaluation. I will not be able to have a good evaluation of the prediction error. I will not be able to have a good evaluation of the error that I make when I have new data that comes in. So in what I showed you before, we needed to fit first the PCA, then the SVM, and each time we needed to be careful about which data we put in, only to put in the train data. In scikit-learn, there is the pipeline object that enables us to chain unsupervised transforms with a supervised step. So if I want to chain a PCA and an SVM, I can do this using the pipeline applied to, and the way I will build it is first I will give it a PCA, so a PCA model with the corresponding parameters, and then I will give it an SVM. And then the pipeline is an object. And like every single scikit-learn object, I can fit it on the data. So I can fit it on X train and Y train, and what it will do is that it will first fit the PCA on X train, and it will transform X train with the PCA, and then it will pass this to the SVM, and it will fit the SVM. So it's doing this chain of transformation for me. And so this is nice because then I can use it as any scikit-learn classifier. I could, for instance, put this in a cross-val score to measure its error. And so one thing that I could do, and I'm going to skip over to this part, is that I could chain everything together, and I could put this pipeline inside a grid search CV to tune all the parameters of the pipeline. And I believe that I have this at the end of this chapter. Okay, to find this, I will need to go to the example. The eigenface is example. And so if I go to the, I have the pipeline. Oh, no, I don't have it. Well, so I don't have this example. Well, I can show you how it will work. I have 5 minutes and I will show you how it will work, and I will have to type along. So I'm going to open the notebook. So I'm going to open the notebook in Jupyter. So here's the notebook. Is there a way to reduce dimension using class information? You can use an LDA to do this, but there's no, I would say there's no good way, no way that satisfies me. So I can run all the cells. So what this will do, if I run all the cells, is it will reproduce what I was showing you in the web page. It's just running them. And then what I will need to do is I will need to use, so it's running them, and then I will need to use grid search CV. So I'm importing grid search CV. And I will, so what I will do is that I will create a grid search CV. I'm going to call this grid. And so I will create a grid search CV. I will give it as a model my classifier. And then what I want to do, so my classifier is a pipeline. We can look at the classifier And it's a pipeline with two steps, PCA and SVM. And what I want to do is I want to tune the number of components of the PCA. And so I will do this by defining a specific parameter grid. So the parameter grid of the grid search CV takes a dictionary where the names of the keys are the names of the parameters that I want to modify. And I want to modify the end component parameter of the PCA. And the way I write this with scikit-learn is I write PCA underscore end component. So it means I'm modifying the end components parameter of the PCA. And I'm going to try several values, 10, 50, 150, and 300. I hope this won't take too long to run. Okay, and I think this should be good. Okay. So now I can fit this to the data. Oh, I will add verbosity. I will increase the verbosity to see things better, and I will use parallel computing to go faster. Okay, I can fit this to the data, and what you can see is that it's doing many things in parallel. It's splitting the data. It's doing a cross-validation loop, and it's varying the number of components in the PCA. Oh, so it has already finished. And so then we can look at what the parameters it has chosen. And it has chosen the best parameter was 150. So it was the one that I already had before. Okay? And this was just a short introduction. We're out of time, but it was just a short introduction. However, I covered the most important things, the API of scikit-learn with the model, fit, transform, predict, cross-validation to measure prediction performance and to choose the best model or the best parameters, and grid search to do this in a clean way, and pipeline to chain several transformers. Thank you very much for listening, and thank you very much to Amanda for the translation.